Here I want to do an example of how to find a missing coordinate from an endpoint using the distance formula. So here we have a line segment. We're given one endpoint and part of the other. We have the y coordinate. It says what is the x coordinate of point D if the segment is 10 units long. Okay, so we know the distance and we know a coordinate and a partial coordinate. So I'm going to write our distance formula at the top here just to remind us. So our distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And so now we still have information we can plug in. So I'll label this x1 and y1. Okay, that's what we'll call this point. And we'll call this point x2 and y2. And then this, of course, is our distance d. So now we can plug in this information into the distance formula, and we will be missing a piece of it that we will have to solve for. So our distance is 10. X2 is going to be this missing x coordinate, so I'm just going to call that x. So we've got x minus x1, which is negative 10. Plus y2, which is 11, which is 11 minus y1, which is 17 squared. And now I can clean this up a little bit, simplify. So x minus a negative 10 is x plus 10. And then 11 minus 17, that's negative 6 squared. And we can simplify this as x plus 10 squared plus 36. And so now we have this radical equation. Okay, and so some of you may need to review some of the algebra that we're going to do here, which is fine. You can find some videos on Khan Academy, or we can talk about this a little bit in class. But to solve this radical equation, okay, we need to get rid of the square root on this side. And so as long as I do the same thing to both sides of the equation, they will still be equal to each other. So in order to undo something, undo the square root, okay, I'm going to square that object. Okay, those are inverse operations. So if I'm taking the square root of something, okay, if I take the square root of 4, which is 2, well, if I square 2, I'm going to get, that's going to undo that. That's going to put me back at 4. So I square both sides, and I get 100 on the left side. And now squaring this square root, this radical equation, is going to get rid of that square root. So I'm just left with what's underneath. So I have x plus 10 plus 36. And so now I have an equation, a quadratic equation, and I can go about solving this first by subtracting 36 from both sides. So that gives me with 64. is equal to x plus 10 squared. And so now I want to get rid of this square, okay? Since everything on the right-hand side is squared, to undo that, I can take the square root, okay? As we saw up here, these two are inverse operations, so they're going to undo each other. Then I have to do it to the left-hand side as well. And the square root of a positive number is going to yield two solutions. So the square root of 64 is positive 8, but it's also negative 8 because negative 8 squared is also 64. So I'm going to write this as plus or minus 8 is equal to x plus 10. And now I have two situations I need to consider. This is going to produce two equations. So one, I want to know when positive 8 equals x plus 10. And if I solve that equation by subtracting 10 from both sides, I'm going to get x equals negative 2. And I also need to consider when negative 8 is equal to x plus 10. And if I subtract 10 from both sides, I get x equals negative 18. Okay. So my equation has produced two solutions. I need to see which of these solutions is going to fit this problem. And so if I look at my graph here and I consider that, okay, the x value of this point is negative 10. Okay, and the point I want is over here. So if I think of my number line, okay, if negative 10 is here, and I consider my two solutions, well, negative 2 is going to be down on this end, and negative 18 is going to be out on this end. Okay, so the only x value that can coincide with this point is the negative 2. So this is going to be our missing x coordinate for this point. Okay. So that's how you can find a missing coordinate of an endpoint by using the distance formula and working backwards.